Welcome to another episode of the Data Science Leaders Podcast. I am your host, Dave Cole. Today's guest is Karin Chu. Karin is the VP of Data Science and Digital Analytics at Peapod Digital Labs. She holds a PhD in statistics from Texas A&M. Welcome, Karin.
Thank you. Hi, Dave. Happy Friday.
Happy Friday. It's great to be here. The topic, the agenda for today, we're going to be talking a little bit about the supply chain challenges that are the global supply chain challenges that are going on today, thanks to COVID, and how that has that created an opportunity maybe for your team. It's been an area of focus for your team. The second topic is diving into the role of the ML engineer. Why do I need to have an ML engineer on my team? What does an ML engineer do? What does the career path look like for an ML engineer, et cetera? And then last but not least, we talk a lot about in the DSL podcast about the importance of communication as a data scientist and also as a data science leader. And I know you have a unique perspective there. Before we start diving into the agenda topics, maybe you could tell me a little bit about Peapod Digital Labs. What is Peapod?
Yep. So Peapod is the e-commerce and the digital arm for hoteliers. So in the U.S., it may be something that's foreign to a lot of the consumers. However, hoteliers is one of the world's largest grocers. They're based out of the Netherlands. In the U.S., our stores are mostly on the East Coast. So, for your East Coast listeners, they would have heard of the giant brands, Hannaford, Food Lion, Stop and Shop, and most recently, the acquisition of Fresh Direct in New York. So the Peapod Digital Labs, or PDL, we enable both the online and the omni-channel experiences for our grocery customers. My role as the VP for Data Science and Digital Analytics team for PDL, we build out all the algorithms for the online experiences for the customer, as well as all things that are Google Analytics related. So all the tagging, tracking of the data, monitoring where do the users go, what kind of experiences are they having, and then of course the e-commerce, the loyalty metrics. So basically the end-to-end user experience from an analytical perspective.
Got it. And do you do that across the various properties that the
Yes.
various grocery store chains that
Yep.
hold? Yes. Very interesting.
Absolutely.
So I imagine just the nature of your business, that the global supply chain issues potentially have introduced sort of an opportunity for your team to apply data science to some of that. Is that true?
It absolutely is. So my training is statistics, right? So classically trained statistician. So for statistics, everything we do is based on historical data. And, what kind of patterns did we see last year, last month, last decade, right? And layer on top of that, you have seasonality. However, what happened with the COVID, the result of COVID is that none of those assumptions hold anymore, right? You don't have any, this is once in a lifetime, once in a decade events. We don't have any historical data to look back on. We don't have any sort of seasonality to speak of, really, to using our algorithms. So that is important because all the models or the machine learning algorithms that we have built in the past, they don't work anymore. In statistics, there's a whole science called Bayesian statistics, which is looking at your priors. That doesn't work here. Right, so
there are no priors.
There are no priors to use. So what do you do, right? So there are a few methods to manage supply chain issues. Traditionally, you have the standard supply chain management approaches via operations research, right? So finding the optimal path that will minimize your costs. And then that's one approach. And there are multiple assumptions with that as well, which, with COVID, those assumptions no longer hold. So that's one challenge. The other approach is your very classical models, your demand and forecast time series models, simple regression models. Those, again, all depend on your historical data. Those also no longer hold. Or you can still apply them, but there's going to be a lot of variability in your forecast to the point that, it's kind of causing doubt on the accuracy of your numbers. So in the absence of all that, what's the alternative, right? So from a tactical standpoint, there's a whole family of algorithms or logic called recommendation systems. So recommendation engines, it's really looking at, if persons A and B are very similar in terms of their shopping behavior or in terms of where they live, their preferences and whatnot, if person A tends to buy items 1, 2, 3, then person B likely will also buy items 1, 2, 3 with a certain amount of likelihood. So if certain items are out of stock, are there other items that we could recommend to this particular customer based on what others like them have purchased in the past, or based on other items that are similar to the ones that are out of stock? So building a recommendation system in the absence of having historical data is something that we are relying quite heavily on, not just in the grocery business, but you can think about fashion retail. Anytime something is out of stock, you're able to come up with recommendation that could replace that. And then the customer will then subsequently give you feedback, whether or not they're purchasing it, whether or not they like it. And then from there, you're able to update your recommendations and all in real time. So it's not, so in a perfect world, you will have the supply chain fixed. You'll have your optimal delivery path, your how to minimize the cost. Layer on top of that the forecast of how much inventory you need to keep on hand, and then all the recommendations that similar items or similar brands, similar people. But in the absence of all that, there is still tools that can be used to help manage that process that won't rely on having these prior knowledge in place. And that would be something that I think organizations in this environment, it may behoove us to look into that type of approach.
So to be clear, when clearly hopefully COVID is a once in a lifetime sort of an event, right? And the way it has impacted, focusing on your industry, like folks going, to the grocery store, it is changed, what you purchase, from in the early days of COVID, purchasing, tissues and hand sanitizers and things like that. But also, like more recently, as the economy has sort of started to improve and bounce back, but maybe not everybody has sort of, they're not the workers who on the supply chain. There's this big surplus of demand for humans to help get the help with that supply chain, and the sort of the demand has increased faster than we can get some of those folks back to work, and that has created these sort of supply chain disruption. So when you say that we don't have the historical data, are you talking more on like the unique elements on the demand side of the types of things that people are purchasing is different than what they have historically, or is it more on like the sort of the supply chain side where goods that normally would have been very easy to have sort of been purchased to meet the demand are that's no longer the case, and you're having to find other similar products or whatnot and put those in front of consumers?
Yep. So excellent point. It's actually both, right? So it's the products that ordinarily would be available, they're no longer available for whatever reason. Right. So that's on the supply side. Now, on the demand side, consumer behaviors have also changed. So, people are in the early days, like you mentioned, early days of COVID, people are going out there buying tons of toilet papers. That's unheard of prior to that. So how do you incorporate that kind of phenomenon into your algorithm becomes a real challenge. So I would say, there are no priors because your customer behavior, so people's behavior have changed, as well as the amount of supply that is available has also changed. And layer on top of that, the economy has changed, right? So a lot of people are no longer working or were no longer working because of COVID. So how do you factor that into the equation, and then you have the government stimulus coming in. That also, right, at different time points, and that's no longer part of your regular pay cycles. So how do you bake that into the equation? So there's a lot of, I would say, as a statistician, there's a lot of different ways that we can look at the data, perhaps running a lot more simulation, Monte Carlo simulations, for example, putting a lot more probabilities. But these are real challenges, and I think we're in a place in our science where this is something we've not encountered in the past. And one thing though, we do have a vast amount of data that we're collecting today. So it will be very, very interesting to see how we as a community manage that data and treat that data, say 5 years from now, 10 years from now. How do we go? How do we handle this data? Do we smooth it out? Do we incorporate it, set it as a new baseline? What are we going to do with that? I think we're still living through that process right now, but it will be very interesting and very useful to see how this data will be applied for our future studies.
Yeah, my vote is to exclude that data altogether, just so we can wipe this entire last couple of years from memory.
That's right. It didn't exist.
Yeah, exactly. But in all seriousness, though, I have to imagine that there are probably some lessons learned here that might be applicable back when hopefully things get back to normal. Do you agree? I mean, are there some things that you see that you're doing today thanks to COVID that would have been very helpful if you had a new sort of recommendation engine that maybe is suggesting different products pre-COVID? Does that make sense?
It makes sense. So I think there are a couple of things. One is it definitely expedited the growth of e-commerce, right? I think prior to this, there was still a lot of, we're going to build our algorithms. It will be, and this applies to many industries. We'll build our algorithms. Maybe we will put it into production, but maybe we will still go with our business logic. Well, this has thrown that out the window, right? So in this environment, and who knows, maybe there will be more scenarios where e-commerce will become a focal point in our in our economy, right? So if that's the case, we need to be more prepared. So I think moving forward, basically our growth, our maturity as an e-commerce just expedited, like skyrocketed within the past 2 years now. I guess it has been 2 years since the initial COVID lockdown. So there is that aspect. And then on top of that, how do you manage all that data that's coming in, right? So it's all of a sudden, you can't just run I don't know. I don't know. I'm sure the audience are familiar with like Google Colab, Python notebooks and stuff like that. You can't just go and use your notebook and expect to run all these analyses and go live with them. There's a whole process of you build the algorithm, then you got to deploy. So I think this really helped us learn how do we go from running an algorithm in a simple notebook to deploying it in real time, because the entire landscape is constantly evolving. So I would say one of the biggest learning as an industry, and this cuts across both grocery, banking, retail, so on and so forth, is that we had to become very mature, very stable as a platform very, very quickly. And I think there is a humongous lesson learned from that experience that will carry us forward for many, many years, I hope. Also, it's just that mentality. We need to be much more agile, much more flexible in terms of what we need to have in place and who are all the key players, where are all the data coming from. So I could go on and on about that, but I think this has definitely moved us forward by leaps and bounds than where we were 2 years ago.
Yeah, that all makes perfect sense. I mean, it's not just the behavior, like what the customers are buying has changed, but also how they're buying, right? So they're buying, they're buying their groceries now, through a website and having them delivered, thanks to COVID a lot more often, I imagine, than pre-COVID. And that has, put, and because more of the buyers have sort of moved online, that's an opportunity for ML to play an outsized role. And this is a good segue into our next topic, which is talking about ML engineers, right? And what role they've potentially played in helping you roll these models out, very quickly and in a scalable way. So maybe you talk a little bit about like what is an ML engineer?
So that's an excellent question. And ML engineer, I would say it's something that's fairly new to most industry. So I've been doing data science for quite a bit, quite some time. I remember back in the days when you build an algorithm, a model. You build a model, and the model generates some coefficients, some weights, right? And then you just pass those weights over to your tech team. And the tech team puts them into production, the model runs, and everything gets scored, and then out comes the results. That's it. Pretty straightforward. And every now and then, you will update your weights, update your model, call it a day. That's not the case today, right, in the tech environment. So the models are becoming much more dynamic and much more complicated. If you're building a recommendation system, there are a whole bunch of weights. There are a whole bunch of features that need to go in there. And, it's like myriad of data sources. You got your online clickstream data, you got product data, you got shoppers data. You have to be able to combine all that data together and then put that into the model and then generate the output. And then at the end of the day, that model needs to get deployed. And that deployment is no longer, hey, I'm just going to send these coefficients over to the tech team. They're going to implement. It's no longer that simple, right? Because you're talking about hundreds of weights at least. And so in that case, there's got to be a way in which the model can be deployed such that the front end, if a user comes to our website, they click on something, let's say they click on, on jams, strawberry jams. They click on strawberry jams, and boom, on the side, we recommend items that will go with the strawberry jams or jelly. It could be peanut butter, it could be bread, it could be butter, although butter and strawberry jam sound kind of weird, but you get what I'm saying, right? So you can get complementary items off to the side. Well, there's a lot of logic and coupled with business rules that are kicking off in the back end. The process of packaging the data science algorithms and putting that into production such that the model will kick in and receive all that data and generate the output. That is more or less the role for the ML engineer. I think, I know I'm simplifying this. So an ML engineer basically automates the ML algorithms or the models. So I would say it's not DevOps, because DevOps don't really typically deal with data, versus the ML engineer does handle, they take the machine learning algorithms and then package them so they're automatically deployed, automatically trained, scaled, monitored, monitoring the performance. So everything that is wrapped around deploying the algorithm. So that's on the ML engineer side. I know you didn't ask this, but there is another piece to this, which will be the data engineer, right? So in a modern ML algorithm deployment environment, you do have the data engineer on the front end that takes in all the data from all these different sources, the metadata, the clickstream data, and then clean them, prep them, crunch them, create features with them, and then pass those over to the machine learning data scientists who built the algorithm. And then the algorithm is then passed over to the ML engineer for deployment. That's kind of the three pillars in terms of deploying the algorithms.
Yeah, I mean, I can imagine that if you're working with your web team, right, and you are recommending that they leverage a model that your team has built, and that probably it's going to be like some form of like a REST API or something like that. Hey, if you give us these sort of attributes, we'll spit back out a list of products that we would like to recommend to this customer alongside whatever product they're viewing. I have to imagine that they're going to raise their eye and say like, we have certain low latency sort of rules that our users. We want our users to make sure that there's sub-second response time, and we have page load times we're concerned with. And a data scientist might not be expert, right, in standing up an API and making it performant and making it scale to the tens of thousands, if not millions, of users that are hitting the site. So it sounds to me like, at least in that real-time use case, that's where an ML engineer comes into play. And I was about to ask you, a lot of folks want to talk about the sort of the real-time models, but I'd argue that most machine learning models that are put into production are more batch than they are real-time at most companies. I could be wrong, but that's just been my experience. So do you see an ML engineer playing a role in some of those batch models, or do you think it actually a data engineer plays a role there?
So that's a really good question. I think it was still, so the ML engineer would still play a role in that world. When you think about if the model is being called in real time and scored in real time, like for example, user experience on site. Right. If you come to the website and you click on item A, and then because you clicked on item A or item, I don't know, pick an item, an apple or a shirt, right? Mm-hmm. Depending on which industry you're talking about, it leads you to a different site, a different page. So basically, based on your experience, your customer journey will be different than another customer, right? So that would be more of a real-time response. Right. So in that case, obviously, an ML engineer and also DevOps will play a critical role in mapping that out. However, if it's something like, you could theoretically run recommendation systems or search algorithms with the items already scored and put into a table somewhere, right? So in that case, the model, I'm air quoting here, your listener can't see that, but your model would then basically be querying a table, right? So right. To your point then, in that case, is it still an ML engineer who's doing that job, or can a data engineer do that? I would say the ML engineer in this case would be responsible for the training, the maintenance, and the upkeep of that model, right? Upkeep of the results of that model. Mm-hmm. So once that person needs to make sure once the model is deployed that the tables are being populated accordingly, that the results are accurate, right? So I would say in that case, it will be a blend between the data engineer who's managing the data lake environment and the ML engineer who's ensuring that the model is being trained on time and any issues, performance monitoring. I would say that would be a blend. In most cases, though, I would say, yes, you could run the model as a batch, the results being put as a batch, but then it's how often do you want to update that, right? I've been in companies where some databases are updated on a daily basis, some are on an hourly basis, and then there are other type of models where you generate a pickle file, and then the pickle file is put somewhere in the environment such that you're constantly calling and scoring it. It's scored in real time. The scores are generated, it's done, thrown away. There's no persistence to that score, but that all depends on how you want to track it. So there are multiple ways, and depends on the use cases, though. But there is one thing I do want to go back on, because you brought up a very interesting point, that the data scientist's role is building the algorithms. And I think, looking back at my career in different industries, I started out in banking, then I moved over to healthcare, and then in retail. I think in the early days of machine learning, when we have these algorithms being built, many times the algorithms are not actually deployed, unfortunately. And the reason is the data scientists or the modelers or the machine learning data scientists, whichever name we are using today, that their role is, the business tended to think their role is both to build the model and to deploy the model. Well, the data scientists or the modelers, they are not familiar with how do you actually package this up? How do you you're kind of building a software basically. How do you do that? They don't. And so it just becomes a very complicated process. Their subject matter expertise is not in the deployment side. Their subject matter expertise is in building the logic, the statistical logic. And some of them, they are also very familiar with the data, the data management part of it. But the deployment was a little trickier. And I think as a result, a lot of the algorithms are not able to get deployed. And when they're not being able to go into production, then you have someone who's manually babysitting them, for lack of a better way of saying it. And as a result, the benefit, the business value of those algorithms are, I think, underutilized. Right. So I think as time progresses, as more and more companies realize that they have all this wealth of data sitting there, how are they going to capitalize on that data? Therefore, let's bring in data scientists. But the algorithms are not deployed. What is the issue? I think through these trials and errors, companies are now beginning to realize, hey, you know what, there's a whole separate class of data scientists in the form of ML engineers that we need to have in our staff so that we can get these models into production. So I think it's one of the evolutions of our science, which is all good. But it was a very interesting learning process, in my opinion, to get to where we are today.
This is a good thing, right? Because if the market is realizing that one of the challenges of getting models into production is like there are so many models that need to make their way into production that like there actually needs to be a new role carved out who are sort of experts in getting those models in production. That's a good thing, right? That's a good thing for all data scientists out there. And it's also a recognition that like, data scientists are good at certain things, but maybe not in others. One thing that you sort of clarify with me, which is great. I want to summarize on the role of the ML engineer is it's not just about deploying the model and working with, in this case, the web team, but it's also in making sure that models performant. It's also making sure like monitoring that model, making sure the result there's no drift and the model is still as accurate as it was when it was first trained, and also just basically being required to do the maintenance of the model in terms of retraining it. So I imagine there needs to be a very strong handoff between the data scientist and the ML engineer, such that they can take on that role. And over time, as you have more and more models in production, right, so too does your ML engineering team, I imagine, grow. And my last question on the ML engineering topic is I'm interested in like, where are you finding these folks? Like, what does their background look like? And then what are you telling them in terms of like their career path? Like, what does their career path look like? Yep.
So I've built several data science teams throughout my career. I think the one I'm leading right now, this is like my fourth data science team. And so through a lot of, when I say trial and error earlier on, that was also my journey.
As well, yeah.
Yeah, me too as well. So, my journey of going through this process of what works best. I would say, I would say the best operating model from what I've seen and experienced so far is if these roles are under the same umbrella. Mm-hmm. And the reason I say that is to be a successful ML engineer, I think everyone knows what it takes to be a successful data scientist, to be a successful machine learning modeler, right? You need to know your stats. You need to know how to program in Python, in R, PySpark, you name them. And you need to know how to handle data, basically. So that is, a successful technical data scientist, ML modeler. To be a successful ML engineer, in my opinion, the experience has been that I think you need to know a little bit about the algorithms, right? Because at the end of the day, that handoff between the modeling team and the engineering team is, here's my model, help me deploy. But you can't just take it without understanding, okay, these are the output that I should be seeing. These are the inputs I should be getting, right? So there needs to be a little bit understanding or appreciation of what the algorithm does, how the algorithm is built, such that if the algorithm breaks during training, breaks during performance monitoring, the engineer knows what to look for and potentially triage or fix them. Now, if the actual foundation of the model breaks, then it has to go back to the data scientist. But when it doesn't, most of the time it won't. That it's really up to the engineer. So in order for the engineer to be able to troubleshoot, they need to understand kind of how the model works. So I would say, the engineer needs to have obviously some basic understanding of how the algorithm works, and of course the data component of it, and then the programming of it, and how to link that up to the front end, building the API, building the software if need be. So I would say it's more heavier on the engineering side than the data science side, but definitely need to have some data science background, because at the end of the day, they are very connected.
Got it. Great. Let's move on to the last topic, sort of the importance of communication as a DSL. And I know you have, a bit of a unique story in terms of how you got into the world of statistics and data science. And I'd love for you to share that with our audience and to see how it sort of colored the importance of communication in your role as a DSL.
So I came to the U.S. when I was pretty young. I was a tween, so preteen, and I didn't speak any English. Literally, I only knew 2 words, one of which I can't share with your audience. And so, and the only thing that was universal, right, that didn't require understanding of the language was math. So I did quite well in math here. But honestly, I was an average math student back in Taiwan, but came to the U.S. and I was like, well, I'm a stellar math student here. And this was in 6th grade. And then I kind of stuck with math because I did quite well and I liked it and didn't require, communication. However, as I progressed through high school and so on and so forth, because I had to learn the language, and because I also ended up tutoring a lot of folks through undergrad. I had to learn, like, how do you explain sine, cosine? Why do you need to know this type of stuff? Complex number, what the heck is that? How can a number be negative? I had to explain all this concept to the students, right? And so it became very transparent to me. Communication is very important. And then that kind of led me down the path of, all right, I finished with my math degree. Now I got to go on. What am I going to do? So I decided to go into statistics, which is basically applied math, but in a more probabilistic realm. And then moving into getting my doctorate, I got my PhD in statistics from Texas A&M. And throughout that entire journey, I continued to teach classes, to do talks, and so on and so forth. And I think what I walked away after I got my PhD, what I walked away with was, while I enjoy doing, stats, building algorithms, models, what I really enjoy doing was knowing the models I built have practical use cases in a real world environment. And so in order for that to be the case, in order for me to do that well, I need to learn how to communicate. Because otherwise it's really like, then if no one understands why I'm building certain things, or I can't, relay the value of my model, to me, that's not what I was looking for. So I continued down the path of staying in industry and then, doing more education, doing more training. I would say, the longer I've been doing this, the more value, or the more important it is to me that we need to be able to communicate. And I think one of the biggest challenges I have seen throughout my career, I've been doing this for a long time, throughout my career, is that, we have businesses know the value of data, and they know there is value in using machine learning algorithms. However, how do you connect these algorithms to the day-to-day business value? That's a real art and a challenge in itself. So if you have a team that's focusing exclusively on building the most accurate predictive algorithms, But you really have to ask them, what is the value? What is the ROI? What is the conversion rate? What's the add to cart rate? So on and so forth. What's the lift? I think really at the end of the day, that's where we need to be heading towards, is how to measure the actual value, because you can build the most accurate model, but how much revenue does it drive? I know those are not easy questions to answer, and if you ask a data scientist, it's going to be a tough question. It's a tough question anyways, and you're asking a data scientist who's focusing on building the models. It's a tough question to answer, but that is a tough question that needs to be addressed. However, in order to make sure your models are addressing those business values in the most efficient and effective way, you need to understand the business, right? Because otherwise your business is asking you one thing and you end up building something totally different. That's not sustainable. So you need to understand the business. Well, how are you going to understand the business? You can't understand the business by just sitting there working and programming on your own. Not saying that's not a good thing, but there are different aspects to our roles. So in order to understand the business, you need to be able to communicate. You need to be able to speak the business language. So if you're working in fashion industry, you need to understand what's a SKU, what's a style. If you're working in grocery business, again, you still need to understand what's the SKU, but what's the seasonality and things like that. So I think really just getting down to the business language, understanding, what their needs are. All this is wrapped around communication. So data scientists, I would say in this day and age, there are multiple hats that data scientists need to have at their disposal. And being a good communicator is definitely one of them.
Definitely. Well, I learned a few things there. I think when you were talking about communication and talking to the business, I mean, in my experience, when you start talking about ROI and lift and conversion rates, like that's their language, right? Like understanding the importance of the sort of the outcomes of the models. That sometimes, not always, their eyes will glass over when you talk about the how and sort of how you built the model and what algorithms you used and so on. I think some of the better folks on the business side are interested in that, and they're also very interested in the features and what features are primary contributors to the accuracy of the model and so on, because that informs potentially the business decisions that they make down the road. The other thing I learned is that DSLs out there need to be hiring from Taiwan. So that was the other thing I learned. Yeah.
That was definitely a very interesting experience growing up.
Yeah, well, I can only imagine, because having grown up in the U.S. and not having to deal with coming into a foreign country and learning a language, clearly you learned a lot along the way, and also it sounded like you were giving back, like you were teaching others, not just in statistics, but also it sounded like those who had similar sort of language barriers as well. And I think that's also one way in which to hone your craft and hone your skills, is to teach others. I think sometimes that's the best way to really understand a subject extremely well. So I had a blast. I mean, today we discussed
Likewise. Thank you.
The global supply chain issues and how that's impacting your world, Karin. Also dove deep on what it means to be an ML engineer and why data science teams need them. And then last but not least, talking about the importance of communication. So thank you so much for being on the DSL podcast.
Thank you for having me.
If people want to reach out and chat with you, can they hit you up on LinkedIn?
Of course, anytime. Send me a note on LinkedIn.
Well, thank you so much, Karin. It was a blast.
All right. Thank you, Dave.